Yes, my dear friends, good evening to all. Tell me, am I audible, visible now? Audible, visible now? Okay. Everything is perfect. Just tell me. Right? Yes, my dear friends, good evening to all. Just confirm once. Audio, video is clear now? Everything is clear? Just 1 second. I think everything is clear. Let me confirm once.
Look at my acne. I've been using neem, पर कुछ बदला ही नहीं.
Yeah, I think everything is clear. Okay. Yes, very good evening to all. Subham, Nilesh, everyone. Good evening to all. So, my dear friends, what is the agenda of today's session? Tell me, what mechanical engineers, what you have to do today? So, in this session, I have to see most important question of production engineering that directly we can expect in your exam, or question difficulty level, or question pattern will be same as you will see in your actual exam. Here I have come with the question. Just I am going to be go overview. So you can see all these questions with the pure diagram, because our team and YourPedia strongly believe if you see anything, see the diagram, it will be remember for a longer time, right? That's why if you follow my session, usually you have to be seen. I will come with the various types of diagram, various types of video, so that it will give the more clarity about the concept, right? And usually प्रोडक्शन वैसे भी बदनाम है, स्टूडेंट सोचता है कि यार टफ सब्जेक्ट है, right? It is a tough subject, and getting a score is tough, but really I'm telling you, this is very interesting, very easy topic. Just the thing is that you must have a good mentor. That is the only condition. Rest thing all are very easy. Today I all elaborate all that things, so that all are just overview. Now without taking any further time, let's start the session. Okay, before that, tell me, how is the energy today you have? First tell me, everyone, your energy is high now, like me? Yes, all this I will discuss today with the question, solution, all this, so that will not get any difficulty in any question, and it will be set in your mind for a longer time, at least till the exam. I am damn sure about that. Okay, sir, all that I am going to be discussed here. Yeah, very good evening to all. See, that all are okay. So my dear friends, now I am not going to waste your time. Already I am 10 minutes late. Let's start the question number first. But before that, as you know, dedicated batch Coal India you have launched, right? Dedicated batch. So here you can join our WhatsApp group, so that we'll get that PDF in that WhatsApp group. 660 post is there, and our paid batch already started from the 13th of May. And in the YourPedia, basically all the mentor is specialized in their field, and they will train you, right? Good evening. Yes, yes, I am telling you now that WhatsApp group is there. We can join that group, and I will share the PDF there. That all are our team. Okay, so my dear friends, and if you have any query, you can touch with us on that number, and that is our just a website. So let's start with the first question. First question on your screen. Now answer that question. That is the question from the metal cutting. Question is that discontinuous chip during machining forms when work is brittle, speed is low, work is brittle, speed is high, work is ductile, speed is low, and work is ductile, speed high. What will be answer number, question number first on your screen? Everyone tell me, what will be answer number first on your screen? Everyone tell me, what will be answer? My dear friends, basically chip are two types, right? One is continuous, another one is discontinuous. Whenever you have material brittle, right? Whenever you have brittle material, है ना, तुरंत टूट जाता है ना, जब काटोगे तुरंत टूट जाएगा. So brittle material always gives discontinuous chip. Always means always, right? Always gives discontinuous chip of irregular shape and size. Means two chip you will take, no, these two have same shape and size. That means whenever you have brittle material, it will be always discontinuous chip with irregular shape and size. So now the question is, sir, option A and B, both is brittle, sir. Now which one I have to be choose, sir? Which one? Speed is low or speed is high? Which one is favorable condition? Yes. Which one is the favorable condition for the discontinuous chip? Now comment all of you. What? What speed is low or speed is high? Which one you have to be choose? My dear friends, why the discontinuous chip is going to be formed. Just try to understand. Suppose you have a one chip like that, you are going to be cut. Okay. And what is happening? This is your chip. Okay. This is your chip like that. This is your chip. Okay. This is your chip. Because of the friction at the rack face, what is happening? Because of friction, the crack is going to be generated. Crack is going to be generated. This crack. Now, if this crack will get sufficient time to reach from there to there, this will get the discontinuous chip. If the crack is formed and they will get the sufficient time, we will get the discontinuous chip. Now tell me, if speed is high, what is happening? This crack will not get sufficient time to reach from there to there because speed is high, chip velocity is high. Before moving crack there to there will be contact will break. So always keep in mind, brittle material and speed is low is the favorable condition for the discontinuous chip. Whenever you have brittle material, doesn't matter whatever speed, in both the case you will get the discontinuous chip. But the question is that since here it is mentioned are high and low, then which one I have to be favor more? In that case, my dear friends, you have to be favor more low speed. Now here I have came with the diagram. You can see there, right? Here we can see this work and tool. Whenever brittle material is there, it बहुत जल्दी टूट जाएगा. That's why we will get the chip like that. And favorable condition what? Speed should be the low. That is the most favorable condition for the discontinuous chip. Whenever you have ductile material, we will get the continuous chip. But yes, keep in mind, if the ductile material is hard, then we will get the discontinuous chip with regular shape and size. But if ductile material is soft, we will get the continuous chip like in case of mild steel. So that all thing keep in mind. Here we can see the whole diagram I have came with. Fracture ahead of the tool and form discontinuous segmentation chip. That all thing, whatever I have told you, everything is written there, and I will share that PDF in the group. Okay. So work is brittle and speed is low is the one of the favorable condition for the discontinuous chip, especially in the brittle material. Okay. Now I will come on that question. Before that, this is a numerical. I will come on that question. Before that, I am coming to the next question. That is the next question. Question is that the angle between the tool face and the ground and surface of the flank is known as leap angle, rake angle, clearance angle, or nose radius. What will be answer? Everyone answer that question. And yes, you have to be pay by like the session, right? Everyone have to be pay. How? You have to be like the session. So yes, that is the next question. The angle between the tool face and the ground and surface of the flank. So my dear friends, what will be answer? Waiting for your answer. Okay. Meanwhile, I am going to be draw. Suppose that is one of your work material, that is your machine surface. Okay. And this is your tool, my dear friends. This is your tool. Okay. And this is your chip. This is moving with the velocity. We can say VC. Okay. My dear friends, that angle is called rake angle. That angle, if you are going to draw perpendicular on the rake surface, this is called alpha rake angle. This is called your flank. Right? This is called your flank, and this angle is called is what, my dear friends? This angle is called is what? Tell me. The angle between the tool face and the ground and surface of the flank. So this is called clearance angle, and this is called leap angle, my dear friends. That is called leap angle. So what will be answer of that question? What will be answer? Yes, right. So that will be your answer is absolutely right, and answer is what? Leap angle will be the right answer. So all this we can see here, nose radius, nose angle, all I have came with. This is your flank tool, this is your nose radius. Here we can see, if you are going to draw the perpendicular on the machine surface, so that angle is called your rake angle. And the rake angle basically talk about the strength of the tool, right? Okay, that is the next question. The part of getting system which regulate the rate of pouring of the molten metal is known as. And yes, some option you have. Option A is pouring basin, runner, chalk, or ingot. What will be question number 4th on your screen? What will be answer? The part of getting system which regulate the rate of pouring of molten metal. which thing is going to be control the pouring of molten metal? Anybody can answer that question? What will be answer? Question number third. What will be answer? Option A you are going to be give. I am going to be C here, but option A is the wrong answer. What next? What next? So my dear friends, see here. I have correct answer is what? Chalk. Chalk is going to be control the pouring of molten metal. Here I have came with the diagram. Just focus there, okay? Little bit I am going to be reduced that. You can see here part of getting system and their function. This is your pouring basin. This is your runner, and there we can see in the little bit smaller cross section, and this is called chalk. And chalk is going to be control the molten flow rate, and this is your ingate. After ingate, the molten metal comes into the cavity, and after that they will allow to solidify them, and then we'll get the product. So whenever the question is that which thing is going to be control the rate of molten metal, then my dear friends, this will be the chalk. And day-to-day life you used to say this is chalk. It is going to be chalked, right? Chalk is going to be controlled. So always keep in mind everything I have written here. Pouring basin receive the molten metal, runner convey the molten metal horizontally. This is your runner. Chalk construction in the runner which control the flow of regulate the rate of pouring basin into the molten metal. And ingate they will allow the molten metal to go to the cavity, and after that they will solidify and will get the product. So answer will be the chalk, and I think most of you have given the correct answer. That is good thing coming from you guys. As I have told you that PDF I will share in the WhatsApp group, which is free to all of you. Okay, sir, that is the next question, sir. Question is that, okay, that question on the your PYQ, previous year one question was there, what is the solidification time? That's why I have come on numerical on the solidification time. Question is that 2 cubical casting of the same metal and size of 2 cm side and 4 centimeter side are molded in a green sand. Okay, if the smaller casting solidify in 2 minutes, the expected time of solidification of the larger casting will be, and you have some option. You have some option. What will be answer? Answer everyone. What will be answer of that? You have a 2 cubical casting, right? One size is 2 centimeter, other one is 4 centimeter. And you know a smaller casting solidify in 2 minutes, then expected time solidification of larger casting. My dear friends, listen. Whenever that type of question is coming, now be happy. Why, sir? Because that is a easy question. Why easy, sir? Now, my dear friends, tell me what is solidification time? How you can calculate the solidification time? So we know TS is something constant. This is called Chinov constant into V upon surface area whole square. Right, sir? Yes. K is constant. So remove that. Can I say TS is proportional to V upon A whole square? Yes, sir. Why not, sir? Now tell me, if you talk about volume and sphere and surface area, what will be? Volume will be the AQ and surface area will be the 6A squared. Ultimate what will get? A upon 6. So can you say, sir, TS is proportional to A upon 6 whole square? Yes, sir. So 6 is further constant, na, sir. So remove that. So directly we can say, sir, TS is proportional to what? Proportional to A squared. Right or no, my dear friends? It is proportional to A squared. So can you tell me, sir, TS1 upon A1 squared is equal to TS2 upon A2 squared? Why not, sir? Why not? So my dear friends, here TS1 is given how much minute? 2 minutes. A1 squared, 2k squared. TS2 you have to be calculated, and this is given 4 squared. Simple now. So how much you are getting? So you will get the TS is coming out to be how much? 2 is to 16 upon 4. 4 4 just 16, 8 minutes. So correct answer will be B for Bombay. B for Bombay is your right answer. Right? B for Bombay is your right answer. So now that question has been asked in your PYQ. Previously that question has been asked. So most probably you can expect one numerical on that, and it is easy numerical. And for more clarification, I have came with the diagram. Here we can see, my dear friends, that is 2 centimeter, size of the casting. Here 4 centimeter. Everything is given. Now put that value in the equation, and after that we'll get the answer. My dear friends, listen. Whenever that type of question is coming now, in which various thing is there, here we can see In this formula, you talk about volume, surface area, constant is there, several things is there, out of which only one thing is variable according to question. So always try to convert the question in the form of variable, whatever is going to be changed. That's why we have seen I have calculated V upon A, and I have just calculated the relation between the TS and A. Once I get the relation, it will be easy to solve. Right or no? That's why I'm telling you that thing is easy to, getting more marks in your exam. That is the next question, my dear friends. Which of the following best suited for the production of hollow pipe? You have to make a hollow pipe. Centrifugal casting, investment casting, continuous casting, hot chamber die casting. What will be answer of that question? What will be? What will be, my dear friends? What will be answer of that question? Anybody? Yes, whatever you are going to be see. Okay, Satya, thank you. Cyst, well, A for apple. That time everyone is going to be give the answer. Okay, a student thinking, okay, sir, at least one question and now the answer, sir. Huh? Centrifugal casting. Now, sir, how the centrifugal casting works, sir? Really, that is a important thing. So, my dear friends, no, you will never forget. See, that is your centrifugal casting. This is going to be rotate. This is one of the mold which is rotating. Okay, after that, this is you have a ladder. Through ladder, you have to put the molten metal in that. Now, just imagine if they are going to be rotate, you are going to pour the molten metal. So, molten metal is what? Centrifugal force will act. And because of centrifugal force, the molten metal go, away from the center. So, you will get the hollow product. Whenever you have to be get the symmetrical hollow casting product, generally, I am going to prefer the centrifugal casting. And it's important going to ask in several times. Lot of question is also they can frame on that casting, especially whenever you talk about the cast iron pipe. Cast iron pipe generally going to be made by the centrifugal casting. And simple thing, they are just going to be rotate, allow them, put the molten metal, allow to solidify, and will get the better product. And yes, they have, even you can get the hollow product from the sand casting also. But in the sand casting, what is the issue? Surface finish is very bad. But in that case, we will get the excellent surface finish. That is the good thing. Now, rest, anybody can tell me what about the next option if I talk about? What is investment casting? What is continuous? And what is, hot chamber die casting? Comment your answer here. And I know you will not comment. Still, I am positive people, right? Now, plastics are generally made by investment casting, injection molding, cell molding, or continuous casting. What will be the answer? Question number 7. Plastic parts generally going to be made by which process? Investment, injection, cell molding, continuous. Waiting for your answer, dear. Waiting for your answer. I am damn sure most of you make a mistake in that question. But from today, I want to make sure you will never make a mistake in that question. I am damn sure about that. How much you are sure, sir? Why you are sure? Yes, because I am have a better explanation. That's why I am sure. See, this is injection molding. Sir, why it is called injection, sir? Why it is called injection? Because it is looking like an injection, sir. That's why it is called injection molding. Correct answer will be injection. How it is happening? You have a one hopper. In hopper, you are going to pour the plastic, some plastic material, because you have to get the ultimate product, the plastic. Obviously, in a raw material, you will use the plastic. So these plastics are there. After that, we can say they are a heater. Once this plastic comes through that, hydraulic cylinder, they are going to be compressed that way. And there is a heater we can see. Through that heater, they are going to be heat at least till the more than their melting temperature. And after that, that will come in the liquid form. Here we can say liquid form is there. After that, you have to be inject like an injection. You have to be inject, give the more pressure, and this will come and will give the whatever desired shape you required. That's why whenever you talk about plastic molding, whenever you make any product by using the plastic, you are going to prefer the injection molding. Now, question is that why it is called injection? Why? Because do you think it is like injection? It is like injection, no? That's why it is called injection molding. And simple concept is there. You have a heater. You might have seen, my dear friends, especially you travel in the railway. Some people will came to collect the bottle. What they did from that bottle? Yes, they are going to be after that refined, and will get the various type of product by using that, plastics and all that. Simple concept. Hopper put in the some powdered form, after that they will get heated, they will get melted. Once they get melted, give the sufficient pressure through the hydraulic cylinder, and they will, whatever shape you require, they will give and will get the desired shape. That's why it is called injection molding. What is the steps, sir? Simple, we can see. First clamping, then you are going to be injection, after that allow the time to cool, after that mold you have to be opening, and then we'll get the product. So always keep in mind that answer. Various times that question has been asked in different exam. That is the next question. Connecting rod generally manufactured by which process? Option A, casting, drop forging, machining, offset forging. What will be answer? What will be answer of that question? Connecting rod is generally manufactured by casting, drop forging, machining, or offset forging. Connecting rod you have to be made. What will be answer in that case? Yes, that time everyone is going with, okay, tell me, is casting is wrong? Do you think casting is wrong? My dear friends, if I will tell you, casting could be also right. But suppose in the option, if more than one answer is looking good, in such case, you have to prefer the most suitable answer. Even I can prefer the casting if I want. Yes, but in that case, I will not get better surface finish, sir. Need further machining, sir. Exact dimension, getting exact dimension is a complicated in the casting, sir. But I can get. So I have drop forging. Now student can think, sir, what is drop forging, sir? Their name indicate drop, means something you have to be drop. How they look like, sir? How they look like, sir? See there. Simple drop forging. See, this is your ram, this is your die. डाई मीन्स सांचा, खांचा. नहीं बोलते डाई बनाओ, खांचा बनाओ. जैसे तुमको प्रोडक्ट बनाना है वैसा तुम खांचा बना दो, डाई बना दो, राइट? सो दिस इज अपर डाई, दिस इज लोअर डाई, and this will be in the form of what? Whatever you have required. I have to need the connecting rod, so it will be in the form of connecting rod. This now this will come, since this is a heated metal, obviously that could be upper or lower the decrystallization temperature. लीक क्रिस्टलाइजेशन ऊपर भी हो सकता है, नीचे भी हो सकता है. दैट डिपेंड करेगा आपने कोल्ड वर्किंग कर रहे हो, हॉट वर्किंग कर रहे हो. व्हाटएवर यू विल डू, दैट रैम अपर डाई विल कम, और ये जब इस पे आएगा, सिंस इट इज ए हीटेड मेटल, तो क्या हो जाएगा, जैसा शेप रहेगा डाई का, दैट शेप यू विल गेट, एंड आफ्टर दैट विल गेट, अलाउ देम टू सॉलिडिफाई, अलाउ देम टू कूल, और जब ये कूल हो जाएगा आपका प्रोडक्ट बन जाएगा. सो दैट इज कॉल्ड ड्रॉप फॉर्जिंग. Why drop? Because you are going to be drop that ram with the upper die. This is going to be drop over that. That's why it is called drop. Why forging, sir? Because here I am going to be shape the, what you are going to be change. You are going to be change the shape only. Forming means shape. Whenever you have to be change the shape and size, in that case you are going to use the forming process. Forming means you have to be change shape and size. Forging, you have to be heat the metal and then you will get. Yes, right. So you have all have given the right answer. Now if you talk, even you can use the casting, but that will not control जो है ना casting में, it will be little difficult. What is offset forging? Offset forging is nothing, my dear friends. In that you are going to increase the cross section like that. Suppose this is the die, it will be something like that. This is, now another thing will come here, it will come on that. After that what it becomes? It becomes something like that. That is called offset forging, right? This is called offset forging. In that you are going to be increase the cross sectional area. So whatever they are going to be asked, you have to be answer. Casting, machining, simple, you have to remove the extra material, is called machining. So correct answer here, drop forging. And good thing is that most of you have given the correct answer of the drop forging, and you will get the completed connecting rod after forging, and you will get that product. Okay, now come to the next question. The cutting force in punching and blanking operation mainly depends upon. You have to do the blanking and punching operation. Then which type of force is involved there? Tell me everyone. What will be answer of that question? The modulus of elasticity of the material, the shear strength of material, the bulk modulus of material, the yield strength of material. What will be answer? Answer fast, waiting for your answer. In day-to-day life, yeah, you used to say I have to be punch. Like in your college day, remember your college day, stationery shop पे कितना जाता था? So you have to be do these two piece of paper and you have to be punch staple करना, नहीं बोलते कि staple करो, right? तो इसमें कौन सा force की requirement है? Which force? No, my dear friends, yield strength is the wrong answer. Modulus of elasticity is the wrong answer. Bulk modulus of material is the wrong answer. The shear strength, my dear friend, shear strength. How, sir? How, sir, shear strength will be the right answer? So, my dear friends, see, this is one of the sheet. It is visible to you. Tell me, should I zoom more? Visible to you? This is punching operation, right? This is, you have one of the sheet material. Sheet, right? This is one of the sheet material you have, like that. Sheet. Sheet means thickness is less. So you have a sheet material. This is punch. Punch will come and they will tear off from that center. This will tear off something like that. So this, which type of force is there, Baba? This is shear force, shear strength. So if you talk about punching, blanking, in this, shear strength play the major role. What strength? Shear strength. Okay. So yes, SIST have given the right answer, but most of you have given the wrong. Now the question is that, sir, what is difference between punching and blanking, sir? Punching, hole is produced in the sheet. Blanking, a flat piece cut off from the sheet metal. Here we can see after operation, this is you are get. देखो जैसे ऑपरेशन से चलो यहां पे करो, निकालने के बाद इफ दिस इज योर मेन प्रोडक्ट, जो तुमने प्रोडक्ट निकाला यहां पे हमने किया, यू हैव अप्लाइड द फोर्स and that product you are getting. If this is a scrap and this is your main material, then it is called punching. But suppose this scrap is your main product, this scrap is your main product and this is your, just you are going to remove that, then this is called blanking operation. So keep in mind both are the same, but the thing is that which one is your base material, that thing is important there. Clearly mentioned there, my dear friends. Here you can see I have clearly written, the punch penetrates the sheet and required hole is produced. Required hole is produced. The material that removed is called slag or punching waste. The punch cut outer periphery of the required piece. This cut off piece is our required blank. So always keep in mind what is the difference between here. We can see punching and blanking. Operation, a hole is produced on a sheet. A flat piece, blank is cut from the sheet. That is the differences. Required piece, hole is the sheet. Here cut off piece is your blank, right? Here you can say the disc is waste. Here surrounding material is the waste. So that is the difference between punching and blanking. Sir, why you are going to be focused that much? Because my dear friends, in the 2020 one question was from the blanking and the punching operation in 2020 Coal India Limited. That's why I have came with that question. Okay, well, so clear to all of you. What further question they can ask, I will see in the class, but that type also we can expect. Next question. In a rolling process, the state of stress of a material undergoing deformation is pure compression, pure shear, compression and shear, tension and shear. What will be answer? In that case, answer everyone. What will be answer here? Question number 10th on your screen. Question number 10th. Everyone have to be answer. Yes. So yes, mechanical people ना बहुत अच्छा होता है यार. हाँ, सब आंसर लगा दिया A, B, C, D all, ताकि किसी ऑप्शन को बुरा ना लग जाए. क्या पता चला मैंने A को लगा दिया तो C को बुरा लग जाए. So you guys have given option A, B, C, D all. My dear friends, if you talk about in the rolling, so both compression and shear is going to be act. How, sir? How it is looking like, sir? Please clarify that. Here we can see, my dear friends, that is your rolling product that you have to be received. This is your plate, and yes, obviously you have to reduce the thickness in that way. So यहाँ पे देखो, this is called compression zone. Before neutral point, you will get the compression zone, and after neutral point, we will get the shear. This is exit zone, we will get the shear. So in the rolling operation, both thing is present, compression as well as shear. Now again we can ask, why will came with that question, sir? So in the 2017, one question was there, in case of rolling, how I can reduce the roll separation force? So option was by reducing the radius. Yes, it was the right answer. So one question was from the rolling, That's why I have came with that type of question, because same question they will not ask. But since they have touched the ruling, so I think they may ask the question from the ruling. Even in the class, obviously, I will practice more question on the ruling. Right, different number of passes required, all different types of question. Number of pass depends on how coefficient of friction, all that I will see in the class. But that type of question we can expect. Even they can ask in the in the metal in the rolling operation, compression is before the yield point, after the yield point, before the neutral point, after the neutral point, at the neutral point, none of these. Like that they can frame the option. So you have to be ready to, if they are going to ask that type of question also, you must have to be ready. Right? So clear? This is called neutral point. Neutral point, no shear, no compression. What is the meaning of neutral point, sir? Neutral point is that point where no compression, no shear. Before neutral point, compression is there. After neutral point, shear is there. But at the neutral point, no compression, no shear. So even they may ask the question, in case of rolling, what is neutral point? They may ask that type of question also. But yes, you have to be ready whatever they will ask. Okay. So clear? Yes, I will share that with everything. Whatever I am telling you, everything is written in that PDF. Whatever I am going to tell, everything. Everything is written, I will share. Don't worry. Now, no need to waste more time on a single question. Move to the next question. Next question. In which of the following welding process, flux in the form of granular are used? I think all of you can answer that question. Right or no? Can I expect mechanical engineers? All mechanical can answer that question. Spot welding, submerged arc welding, TIG welding, and yes, MIG welding. If you are following me over the YouTube, still you are able to answer that question. Doesn't matter you are my offline class or not, online class or not. Still you are able to answer that question. If you are following me every day. Yes, sir. Good. So, in which of the welding process flux in the form of granule is used? This will be the submerged arc welding. Now, sir, why it is called submerged arc, sir? Why it is called submerged arc? So, little bit I am going to discuss. My dear friends, we can see here, this is the granule flux, flux in the form of powder, right? This is flux in the powder, they will come, and we can say here, you can see the arc. Arc is inside the flux. That's why it is called submerged, because arc is inside the flux. So it is submerged, डुमा हुआ है, flux के अंदर डुमा हुआ है. That's why it is called submerged arc welding. First thing. So second thing, what they can ask, always keep in mind, dear friends, whenever you have a thicker section, आपके पास जो एलपीजी सिलेंडर है जिसका स्कार्सिटी था या अभी भी है, देखते हो एलपीजी सिलेंडर को जो तुमने देखा होगा बीच में जो ज्वाइंट होता है, that is going to be made by the which welding? Submerged arc welding. And why? Because if you have a long section ना, thickness ज्यादा होगा, other welding से जाओगे, there could be the spatter loss, and spatter loss is a very bad thing, dear, very bad thing. That's why if you have a thicker section, in case of shipbuilding, thicker section, I am going to prefer the submerged arc welding. Is it clear to all? Is it clear to all? Yes. Here we can see I have given the diagram just for more clarification. This is going to form like that. They may ask in which case no spatter loss, it will be that. So now tell me, sir, that means it is a very good process welding, sir. So can I use for all type of material? No, that is no. Why, sir? Why? You are telling that is a good, sir, no spatter loss. So why not I can prefer in all welding? My dear friends, we have to always keep in mind this flux is always light in the nature with respect to the base metal. Always light. Light means density should be less than that of base metal, so that the flux will go inside and come with any impurities is there. So, but selection of that type of flux is not possible always. जैसे हमको मान लो अल्युमिनियम का वेल्डिंग करना है, तो जो फ्लक्स होना चाहिए that should be lighter than अल्युमिनियम, लेकिन उससे लाइट अल्युमिनियम से हमें निकालने के लिए जो फ्लक्स चाहिए बहुत कॉम्प्लिकेटेड है, यानी कि मुश्किल है. That's why I cannot use everywhere. So that was a few thing about the submerged arc welding. Rest we'll see in the upcoming session. No need to worry. That is the next question. The major difficulty during welding of aluminum is due to its, and yes, some option you have: high tendency of oxidation, high thermal conductivity, low melting point, low density. Answer question number 12. Answer fast. What will be the answer number? Question number 12. Sir, difficulty of aluminum. Aluminum बहुत खतरनाक आदमी है यार. हाँ, aluminum is a very dangerous people in our analysis, right? What answer I am getting here? Okay, apple. What about others? So my dear friends, okay, a student is just going to be by heart. Someone is going to be give the answer C for Chennai, low melting point. That is not a right answer. Someone is going to D for Delhi. D for Delhi is not a right answer. Okay, B and A is left. Okay, B is also there. Okay, so my dear friends, all are the wrong answer. The correct answer is what? High tendency of oxidation. Now we can ask, why sir this is the disadvantage? Why this is disadvantage, sir? Why high tendency of oxidation is disadvantage for the aluminum? Yes, my dear friends, I am telling you. And always I used to say, if you know the cause of anything now, it will be remembered for a longer time. Just know the cause. Okay, sir, what is cause? So this is the molten metal, sir, of aluminum. Okay, sir. This is the Al2 oxide layer, sir. Okay, sir, no issue. But my dear friends, keep in mind, melting point of the aluminum is approximate 660 degrees Celsius, 660 degrees Celsius. But you will get sudden to know, you will get surprised to know their melting temperature is approximate 2000 degrees Celsius. So what is the problem, sir? Yes, problem. Suppose the molten metal is there और ये molten metal आगे आ गया. अब जब molten metal आगे आ गया तो ये molten metal ये तो 600 पे हो गया था, लेकिन यहाँ पे हमको कितना हीट देना पड़ेगा? 2000 देना पड़ेगा. Now tell me, is it easy or difficult? पीछे तो कोई दिक्कत नहीं था, बन रहा अच्छा है. But what about आगे? यहाँ तो हम तो 600 पे काम कर रहे थे ना भाई. आगे आ गया molten metal और यहाँ पे जाकर ऑक्साइड बना लिया. Once they have formed the oxide, अब हमें हीट कितना देना पड़ेगा? सर हमको तो 2000 हीट देना पड़ेगा सर, बट हम तो 600 पे काम कर रहे थे सर. So it will becomes very difficult. It will becomes very difficult, my dear friends. So even the interview they will ask why it is difficult. So we can say because of formation of oxide layer. They will ask what happened. So we can say sir no issue in the backward side, but issue in the upward direction, sir. अपवार्ड में भी लेयर बन गया सर, तो मैं आगे जब वेल्डिंग करते जाऊंगा तो मुश्किल हो जाएगा सर. दैट्स व्हाई इज द राइट आंसर. And I know most of you have given the, not most, few of you have given the right answer. Okay, don't take all credit. Only few of you have given the right answer. Now always keep in mind why. And yes, really I'm telling you, even in the class I strongly believe if you know the cause of anything, na bhai, if know the cause, it will remember for a longer time. इसीलिए स्टूडेंट को लगता है ये मुश्किल है, ये रट लेता है. But try to understand why it is difficult. And once you know the cause, na, it will be easy. And really I'm the class, I'm going to focus on the same thing. Okay, sir, that is the next welding. In which type of welding molten metal is poured for the joining of metal? Gas welding, MIG welding, thermite welding, right? Arc welding. Option E, I am going to be give slag welding. Okay, slag welding, electro slag welding. That is my option, slag welding. Now give the answer of that all. What will be answer of all that? Yes, answer that question number 13 on your screen. What will be answer in that case? Poured the molten metal is poured. What will be answer? CE. Okay, my dear friends, C. The correct answer even in that case will get what? Thermite welding. Now you can ask, sir, what is thermite welding, sir? I am telling you, see, my dear friends, actually in thermite welding what is happening, you have a one cylinder. You can see this is railway track, right? This is railway track. मान लो आतंकवादी हमला हो गया, कुछ नक्सली के एरिया की बात करो, उन्होंने ट्रैक को उड़ा दिया, कैसे करोगे वेल्डिंग? तो इसके लिए you have a one cylinder. Little bit I am going to be zoom out. Okay, so this is one of the cylinder in which you here we can say the iron oxide and aluminum powder will be given in the ratio of 1:3. Aluminum will be 1, then three part will be the iron oxide. That thing you have to be keep in mind. So this, okay, no reaction takes place. Go to the site and you are going to be just put one of the magnesium rod. Once you put the magnesium rod, within 30 seconds, how much second? Within 30 seconds, we will get a very high temperature. Even we get the molten metal in the superheated state. This will become in the superheated state. Now allow them, this is mold, allow them टू कम ऑन द whatever जो आपका रेलवे ट्रैक जो कट गया था उस पे आने दो और यहाँ पे they will welding will get occur, right? Allow them and after that solidify होने दो. Once the solidify happening, ऊपर से हटा दो and your welding will get completed. So thermite welding generally you are going to prefer in case of railway track. Now another thing keep in mind, here you are getting the heat in the form of chemical reaction. So even they may ask the question, in which of the following welding process heat is getting by the chemical reaction? So again it will be the thermite welding. What is the ratio of aluminum and iron oxide? It will be 1:3, right? And even they may ask, what like that they may ask, and why? Because here you are going to pour the molten metal, this molten metal in the cylinder, and from there it is coming from there. That's why you see the question. So what the question is there? Question is there, molten metal is poured, means in the cylinder you have molten metal, after that you are going to be poured. So correct answer will be the thermite welding. Even electroslag is there still. Clear to all? No need to confuse with the electroslag here. Even I know student usually, yes, if in the thermite is not there, then I will I can go with the option, otherwise no need to worry. Gas welding, MIG welding, arc welding, all I discuss in class, so no need to worry. Okay, aluminum powder and iron oxide. Now my one question to all of you, my one question, very genuine question. Tell me why I am going to use here aluminum powder. I know iron oxide तो मेरे को समझ में आ रहा है सर, since this is iron तो हमें iron डालना पड़ेगा, but why I am going to put the aluminum powder, why I am going to pour here? That is my question to all of you, and let me see who mechanical engineers is going to be answer that question. And yes, if you are going to give the answer in the comment box in the next session, I will tell you yes, your answer was absolutely right. Okay, now come to the next question, the welding process which is used for the welding of plastic. Okay sir, plastic, sir plastic से आपको बहुत प्यार है, आपने पहले भी एक प्लास्टिक का क्वेश्चन दिखाया. Yes, the welding process which can be used for welding of plastic, electron beam welding, resistance welding, ultrasonic welding, and yes, arc welding. What will be answer of that question? Yes, tell me my dear friends. Question number 14 on your screen. And yes, do not forget to like the session. Okay, question number 14, Vicky is coming C for Chennai. What about others? Electron beam welding is also someone is telling. Okay, so I am going to be on lifeline. Electron beam welding is not a right answer, my dear friends. Electron beam welding will get a temperature approximate 20,000 degrees Celsius. Baba, 20,000 degrees Celsius. How? Your option be eliminate karo. How electron beam welding? I will get the up to the 20,000, more than 20, sometimes 25,000 degrees Celsius I can get. प्लास्टिक है सर, सोचने वाली बात है. हाँ सर, ये तो नहीं होगा. Resistance welding, arc welding सर नहीं. Always keep in mind, in that case I am going to use the ultrasonic welding. Now we can ask, sir, how the ultrasonic welding is happening? Yes, see how the ultrasonic. तो एक मैं बताता हूँ, तुम्हारा बाइक का की है, अरे गाड़ी का जो चाबी होता है, that is also made by the ultrasonic welding. How sir? How it is happening sir? So see there, simple function is there. See, this is your work material, okay, and after that here we can say high frequency approximate 20 to 40 किलोहर्ट्ज, और ये ना नीचे आएगा और ऐसे ऐसे वाइब्रेट करेगा, ऐसे ऐसे, और ऐसे ऐसे जब इसके साथ वाइब्रेट करेगा तो बिकॉज ऑफ दैट व्हाट इज हैपनिंग, दिस इज गोइंग टू बी हीटेड, राइट? दिस इज गोइंग टू बी हीटेड, नॉट मेल्टेड बट यस इट इज गोइंग टू बी हीटेड. मेल्ट नहीं हो रहा है, हीट हो रहा है. एंड वंस द सफिशिएंटली हीटेड, एंड समझते हो ना, हीट करने से किसी भी चीज का हार्डनेस कम हो जाता है. तो अगर इसको ने सफिशिएंटली हीट किया, हार्डनेस विल रिड्यूस. आफ्टर दैट आई विल अप्लाई द प्रेशर. Once I apply the pressure, joint will take place. That's why in ultrasonic welding, plastic is going to prefer, right? यहाँ पे आया ऊपर आगे, इसके कारण जो वाइब्रेट किया ना, वाइब्रेशन है. That's why it is called ultrasound. Frequency is more than 20 kilohertz. Means in 1 second, ये कितना बार ऐसे ऐसे होगा जी? 20,000 बार. अरे सर, in 1 second that will move left and right. How many times? Minimum 20,000 times. आंख बंद किया खोला, 20,000 बार ये आगे पीछे हो गया. अब समझो 20,000 बार, how much heat? Just sir, heat is generated, hardness reduces, I will apply the pressure, I will get the joint. मैंने एग्जांपल बताया, बाइक का जो की होता है एक मेटल है एक प्लास्टिक है, दैट इज आल्सो गोइंग टू बी वेल्डेड बाय द अल्ट्रासोनिक वेल्डिंग। मैंने यहाँ पे प्रिंसिपल दे दिया हूँ, वी कैन सी देयर part before the welding, ultrasonic vibration start, heat is generated, plastic melt, okay, vibration stop, pressure is maintained, and after that your joint is getting formed. Clear that point to all? Clear? So yes, whenever you are getting the plastic, you are going to prefer with the ultrasonic welding. Not even ultrasonic, कुछ और भी कर सकता हूँ, but according to option you have to prefer that. Okay sir, come to the next question. Yes sir, that is my favorite question. Natural flame cannot be used for welding. Option A, cast iron, mild steel, copper and aluminum, and yes, option D for Delhi is the none of the above. What will be answer of that question? What? आज के बाद ये भी मैं आपको हटा देता हूं, आज के बाद ये भी नहीं भूलना है दिस। फ्रॉम टुडे ऑनवर्ड्स मैं एक ट्रिक दूंगा, इस ट्रिक से आप ये भी नहीं भूलोगे। पहले आप आंसर दो, टेक अटेम्प्ट फर्स्ट, टेक योर अटेम्प्ट। क्वेश्चन नंबर 15, क्वेश्चन नंबर 15, टेक योर अटेम्प्ट। नो वन यार, क्या हो गया मैकेनिकल इंजीनियर्स? कास्ट आयरन, हाँ कास्ट आयरन, चलो गलत जवाब है। नाउ व्हाट अबाउट नेक्स्ट? Okay, copper and aluminum. Okay, C for Chennai is the wrong answer. What about next? What about next? Mild steel is left, sir. Mild steel is also wrong answer. So what will be the answer? Correct answer is none of the above. None of these. How sir? How it is right answer, sir? Yes, I am coming to that point here. In that case, see here. If you talk about in that case, मैं सारा किस दे दिया हूं. If you talk about oxidizing flame, oxidizing means where concentration or you can say the oxygen content is more than acetylene. For that you are going to use copper, brass, bronze, zinc and grey cast iron. Always keep in mind that is for the oxidizing flame. Now why? I will tell you why. I will tell you, just remember. If you talk about neutral, mild steel is there in the option. Mild steel is there. Let me check. Mild steel is there. Then yes, we can go. Sorry, mild steel is there. Okay. Mild steel we can go through, no problem. Neutral is mild steel is there, okay. So for if you talk about neutral flame, mild steel, low carbon steel, aluminum alloy, alloy steel, stainless steel and cast iron, that will be with the neutral flame. Now if you talk about carburizing flame, so in the carburizing flame, high carbon steel, nickel based alloy and certain case I am going to use the cast iron. Now the question is why, sir? Listen my dear friends, in the neutral, suppose you have a, let's assume mild steel, let's assume you have a mild steel and you are going to use the carburizing flame. Just use, you have a mild steel means the percentage of carbon is less. Yes sir. If I am going to use the carburizing flame, in the carburizing flame the carbon is more, sir. So might be possible this carbon will come on the mild steel and their percentage carbon increases. Might be possible, sir. Yes sir. If they increase the percentage of carbon, so mild steel becomes the medium carbon steel. Sir, in the welding, my target is not to change the percentage of carbon, sir. But here, percentage of carbon will change, na, sir. That's why, my dear friends, always keep in mind, whenever you have a neutral flame, mild steel means they are not going to add any carbon. Low carbon steel, aluminum alloy steel, stainless steel, even cast iron also. Cast iron even I can use with the carburizing flame also. Why, sir? Because in the cast iron already percentage of carbon is high, sir. More than 2.1% of carbon, more than 2% of carbon. You know, cast iron is there, sir. So अगर थोड़ा बहुत carbon add भी हो जाएगा तो कोई फर्क नहीं पड़ेगा. If little bit carbon is going to be add, still no change will occur. Right? That's why हम sometimes use the cast iron. Okay. Here the correct answer will be the mild steel. Okay, in the option. Now, if you talk about oxidizing flame, so always keep in mind copper, brass, bronze, zinc, copper alloy and zinc alloy. Generally, you are going to prefer for the oxidizing flame. Sorry, I have given one here. Actually, the correct answer is the mild steel in that case. Neutral flame, you can go with the mild steel. Okay, none of these is the wrong answer. Mild steel is the right answer. Okay, so most of you have given the right in that case. That is a good thing. And yes, I will share that PDF with you. Everything is written here. Acme thread यहीं पे दे दिया उन्होंने. Come to the next question. The operation usually obtained on a smooth and close tolerance hole. What will be drilling, tapping, boring, countersinking, or reaming? What will be answer of that? Question number 16 on your screen. The operation is usually used to obtain a smooth and close tolerance. What will be answer? Question number 16 on your screen. Waiting for your answer. Question number 16. My dear friends, if you have to be obtain the close and tolerance hole, काफी close, in that case you are going to use what? You are going to use the reaming. How the reaming look like, sir? How the reaming? So here we can see this is your reamer, right? This is your reamer. अब देखो, this is your hole and you can see this is a tool, हाँ? So ये बहुत ज्यादा tolerance will get the huge tolerance. Hole है ना? होल में हमें बहुत ज्यादा टॉलरेंस चाहिए, तो मतलब बहुत ज्यादा प्रिसाइज करना है होल को, बहुत ज्यादा प्रिसाइज करना है. मीनिंग इज दैट सो दिस विल कम, दिस विल रोटेट एंड रिमूव द एक्स्ट्रा मटेरियल. Here you can see the tool is looking like that. This is your initial condition before the reaming, and this we can see the after the reaming. Before the reaming we can see it was not much more precise, but after the reaming we can see it is very high precise. So reaming is used to getting the high precise things, right? So always keep in mind. Now I will ask one thing. So here we can say reaming is a machining operation that uses multi-edge. Okay, obviously it is a multi-point cutting tool, right? Single or multi-point cutting tool. So we can say here multiple edges there. So it is called multi-point cutting tool also. Cutting tool reamer is a smooth, enlarged or accurately sized of an existing hole to obtain the smooth and close tolerance. For that you are going to use the reaming. Okay, so types of reamers we can see here, different types of reamer is there, and you can see before the reaming, that is after the reaming. So correct answer will be the reaming of the previous question. Next, hobbing process is not suitable for cutting following type of gears. What will be answer of that question? Hobbing process is not suitable for cutting following type of gears: Asper, helical, arm or bevel. What will be answer? Tell me. Which gear we cannot cut through the hobbing? Anybody? Anybody? Question number 17 on your screen. Tell me. Which? यार इसमें कौन सा टेढ़ा होता है यार? कौन सा गियर टेढ़ा है थोड़ा सा? Which gear is टेढ़ा? देखो थोड़ा सा, मैं I am coming here. See, hobbing, this is your hobbing tool, right? We can see this is your hobbing tool. They will rotate, okay, it will come in the contact and they will make a, we can say they will cut the gear. ये कुछ इस टाइप का आपका गियर कट के आ जाएगा, right? Now see, if you talk about here, right, in this question, answer will be the bevel gear, right? Now not suitable for the bevel gear. Why? If you see the bevel gear, so here we can see this is something tapered, my dear friends, right? This is something tapered. Here you can say taper gear. Hob cannot generate the required involute T. That's why hobbing is not suitable for the production of the bevel gear. Always keep in mind, because there you can see this is something tilted now. That's why it cannot be. But if before that, if you talk about Asper gear, straight, yes, we can cut through that. It is a straight. You talk about suitable, hobbing is not suitable for the bevel. Before that, we talk about any other gear, hob cutting tool, you can cut the other one very easily, क्योंकि ये सब ज्यादा हमारा tilt नहीं है, यानी कि tapered नहीं है, so we can cut. What is this? Just 1 second. Hanged system. Okay. Just 1 minute, dear. Yes. So even they may ask, hobbing process is suitable for. So Asper gear we can cut, helical or that all can cut, but bevel you cannot cut. Even that way they can also ask the question. So be ready for that. Come to the next question. Yes, cutting tool 1841 HSS had which one of the following composition? What will be answer of that? HSS 1841. Which of the following composition will get? Anyone? कितना होता है जी? 18% tungsten, 4% chromium, and yes, 1% is vanadium. Okay, so always keep in mind here 1841, 18% tungsten, 4% chromium, and yes, 1% is vanadium. Directly they may ask, so be ready for that. Okay. Which of the following is used as a dielectric medium in electrode discharge machining? That question has been asked in 2020 also. That question has been asked in 2020 also. So hopefully all of you can answer that one. EDM देखो, non-conventional machining is important here, right? Non-conventional machining is important. Dielectric medium in EDM, what will be answer? Silicon carbide solution, huh? No, that will be the what? Salt solution, silicon carbide solution, Al2O3 or kerosene. So talk about EDM, kerosene based oil you are going to be used. How the EDM is work? Simple, you see here, my dear friends, how the EDM is work. I will discuss in the very details in the class, but little bit I am going to just introduce here. What is happening here? This is yes, see there. Need to do something in that case. Okay. देखो, is it visible to all of you now? Visible now? So how the EDM works? How? So EDM is a non-conventional machining, and in the non-conventional machining, tool and workpiece and tool will not come in the direct contact, right? That is the one of the advantage in case of you can say the non-conventional machine. So here we can say this is your tool, you can select rod, and here dielectric fluid that you are going to use the kerosene, and they will come, and after that some spark will takes place. Because of that spark, whatever extra material is there, that will remove, and whatever you will get the extra material that will be carried away by the kerosene oil, and in that way your machining is going to be takes place. Tool and workpiece is not come in a direct contact. So always keep in mind you are going to use the kerosene here. That question has been asked even in the exam. What is the function of dielectric constant? Dielectric fluid, not constant, act as a electrical insulator, dielectric between the tool and the workpiece, help in sparking, breakdown of dielectric, flushes away the eroded metal particle, that is called debris, from the machining zone, cools the tool and the workpiece, prevent arcing by removing the debris from the gap. That is your EDM, electric discharge machining. Okay, come to the next question. Precision is defined as, how we can define the precision? How we can define the precision? Question number 20. Everyone tell me. The degree of repeatedness of the measuring process, lesser number of control error, lesser number of random error, none of these. What will be answer? Precision, you know. You wish to say, sir, this is very precise. What is the meaning of precise? Huh? This is called degree of repeatedness. You are saying precise. Suppose मैं बोलूं कि यहाँ पे गोली, you know, you have to be just, you know, यहाँ पे गोली चलाना, you have to be just, है ना. मैं बोलूं 10 गोली चलाओ, 10 गोली चलाओ. तुम्हें मैं टारगेट यहां दिया हूं, लेकिन तुम 10 गोली चला रहे हो, सब गोली यहां लग रहा है ना, सभी आसपास लग रहा है ना. तो दिस इज कॉल्ड प्रिसीजन. प्रिसीजन मींस डिग्री ऑफ रिपीटेडनेस. कितना ज्यादा आप रिपीट कर रहे हो सेम रिजल्ट को, दैट इज कॉल्ड प्रिसीजन ऑफ एन इंस्ट्रूमेंट. दैट नॉट नेसेसरी इट विल बी द एक्यूरेट, नॉट नेसेसरी, इट कुड बी और कुड नॉट बी. अगर कोई डिवाइस प्रिसाइज है, इट कुड बी एक्यूरेट, कुड नॉट बी एक्यूरेट. प्रिसीजन मींस सिंपल reproduce the same result same and same again and again. जैसे आप यहाँ, आपको गोली चलाना था, यहाँ पे आपका गोली बार बार यहाँ जा रहा है, 10 बार चला रहे हो, सब यहाँ जा रहा है, तो सब आसपास है ना, दैट इज कॉल्ड प्रीसाइज. माइट बी पॉसिबल आप 10 गोली चला रहे हो, 10 यहाँ भी आ गया, ऐसे है. तो दिस इज कॉल्ड, यू नो, प्रीसाइज एज वेल एज एक्यूरेट आल्सो. दिस इज कॉल्ड प्रीसाइज बट नॉट एक्यूरेट, राइट. सो प्रीसाइज could be accurate or could not be accurate depending upon the scenario. So here I have came with the diagram. Correct answer will be A for apple. Right, here we can see the degree of repetitiveness of a measuring process. This is called what? Precision. Here we can say this is high precise. All the value is going to measure there. So this is very high precise. Here we can talk about low precise. You have to be target there. But एक बार तुमने गोली फायर किया, यहाँ लगा, एक बार यहाँ लगा, एक बार यहाँ लगा. समझ रहे हो कि नहीं? So it is not a precise. So okay, so does not define precision, it is not a precise. Base diagram you can see, repeat the same result multiple times, that is the meaning of precision. Next question on your screen. Basic hole means, what do you mean by basic holes? What will be the basic holes? Question number 21st on your screen. Basic holes, upper deviation is 0, lower deviation is 0, both, none of the above. What will be answer? My dear friends, students usually confuse in the hole. Now tell me, whenever I talk about hole, so hole में आपको अंदर वाला dimension से मतलब है कि बाहर वाला dimension से. Tell me clearly, whenever you are going to design a hole, which dimension is more important to you? Inner dimension or outer dimension? Tell me everyone. Yes sir, inner dimension is most important. So always keep in mind, lower deviation is 0. In case of basic hole, lower deviation is 0. If they will ask, what is the basic shaft? What is the basic shaft? So in the shaft, you talk about which dimension is important? Upper dimension, sir. That means upper deviation will be the 0. That is the way by which you could be able to remember in the exam. Hole means अंदर वाला, अंदर से हमें मतलब है. That means lower. Lower deviation is 0. If you talk about shaft, shaft में हमें बाहर से मतलब है, ये shaft है भाई. You need the external dimension. तो इसमें याद रखने का तरीका है, upper will be the 0. क्लास में आएंगे, then we'll discuss much more about that things. But currently, you guys have given the B for Mumbai is the right answer. Yes, now you are able to answer that question. Accuracy of the instrument. What will be answer? Accuracy. What will be accuracy? The closeness with which measurement can be read directly from the measuring instrument, measure how close the reading to the true size, okay? Different measurement exercise, okay? The capability indicate the same reading again and again for a given measured. What will be answer? Yes, Subham, you are right. B for Bombay. A measured how close the reading to true value. That is called accuracy, right? Means close to true value, that is called accurate. Precision is repeat the same result again and again. You know, precision could be accurate, could not be accurate. Okay, so B for Bombay is the right answer that time. All of you have given the correct. Means you are getting the things. They have you know, given the long hair diagram. Okay, come to the next question. Which of the following statement is true? Answer that question. Which one of the following statement is true? That is the question from the metrology and instrumentation. Answer that question. The go gauge control the upper limit of hole. No go gauge control the lower limit of shaft. The go gauge control the lower limit of hole. The no go gauge control the lower limit of hole. What will be answer of that question? That is again from the instrumentation. You can say the metrology and instrumentation. क्या करता है जी बताओ इसका आंसर इतना टाइम लगाओगे इसमें Yes, go gauge limit applied to the lower limit of hole and upper limit of the shaft. Go gauge limit, lower limit of the hole and upper limit of the shaft. ये सब बहुत डिटेल में बताया हूँ क्लास में यार, पता नहीं अभी क्यों गलती कर रहे हो आप लोग. YZ plane selected as active plane during CNC programming by G17, G18, G19, G04. What will be the code in that case? YZ plane. This is question from the CNC. So my dear friends, remember that XY plane, G17, G18, G19 called family of plane. G17 if you have to be cut in XY plane, G18 if you have to be cut in ZX plane, G17 you have to be cut in YZ plane. Right? So keep in mind that thing. That is called family of plane, because in the CNC you have to be just give the what? That command na कि in that plane you have to be cut. तुम हाथ से जाके काटोगे नहीं ना वहां पे. So if you have to be cut in XY plane, you have to be give G17, ZX plane 18 and YZ plane 19. Try to remember all that point. In CNC program block N10, G01, G91, X52, Z25, G02 represent. I think that all of you can answer. What the G02 representing here? Linear interpolation, clockwise, incremental or absolute? Answer everyone. CNC program G02 बाबा, linear नहीं होगा, clockwise, circular. Try to remember यार all that code. Be ready. They may ask the code from the G code, M code is important. Act of family of plane, incremental mode, absolute mode, linear interpolation, clockwise, anti-clockwise, inch mode, mm mode, incremental, absolute. At least try to remember all that. In course of M code, which one is for the coolant on, coolant off, a spindle change, that you have to remember for the M code. It's important, okay? So here we can say G02 basically represent the clockwise circular interpolation. G01 linear means you have to be go from here to here, 1 to 2, and you have given G02, so they will go like that, okay? If you have given G01, they go like that, directly they will go. If you are given G03, or then it will go something like that, anti-clockwise cutting. That is the next question. A device which hold and locate the workpiece during an inspection for a manufacturing operation is known as. What will be answer? Fixture, lathe, template and jigs. What will be answer of that? Waiting for your answer, dear. Fixture, yes, है ना? Device which hold and locate the workpiece during inspection for a manufacturing operation. This is called fixture. याद रखो, fixture से fix करना. अरे fixture से क्या करना है? Fix करना है, right ना? So device which hold and locate the workpiece during inspection or manufacturing operation. We can see the function of fixture: hold the workpiece, right? Locate the workpiece accurately, ensure all that. That is the function. And here we can say fixtures, okay? Workpiece is there, you are going to hold and locate all that with the help of fixtures. Jigs is also there. What is the function of jigs? You can make a comment. So my dear friends, that's all about the 26 question, 27 question I have discussed. And this was the some expected question from your analysis of PYQ. Rest, if you have any doubt, any query, so join the one of the free WhatsApp group is there. one of the free WhatsApp group is there. You can scan then and we can join. And if you want to join our paid batch, which is already started from the 13th of May, right? So we can directly call us, our team on that number, or we can visit there. And about that PDF, as I told you, there is a mechanical group. Here we can see the mechanical हमेशा अंत में ही आता है, समझ रहे हो ना, अंत में आता है और फोड़ के चला जाता है, राइट? तो यहाँ पे है, we can just scan and join here. I will share the PDF. So my dear friends, that all about the today's session. Now, if anyone have any doubt, we can ask. Otherwise, do not forget to share that session with your friend also, like and all that. And for more understanding, better guidance, production, I am telling you, last year, in 2017, 33 question was from the production, and 2020, 16 to 18 question was from the production. 33 question in 17, 2020, 18 question, right? If you add the material science, on an average, you can expect material science plus production, this weightage approximate 30 to 35% minimum. I am telling you, material science production will expect the 30 to 35% weightage, means 30 से 35 question will expect from the production plus material science. Material science 2017 में थोड़ा कम था, like 10 men, but okay, 2020 it was higher weightage. I will share, right? I think already I have made one video over the analysis of the paper. यहीं पे होगा, देख लेना वीडियो सेक्शन में. Already I have made कि कितना से कितना क्वेश्चन आया हुआ था, so we can see that also. Okay. So my dear friends, that all about the today's session. No induction, industrial, not induction. अब मुझे खाना पड़ेगा लग रहा है. Industrial से 3 question plus 1 question. 3 question was in 2017, 1 question was 2020. Yeah, I have made the detailed analysis, right? Go and watch, all the subject will get. This is excluding from the industrial, right? This is excluding from the industrial. Okay, Shubham. So my dear friends, now allow me to go. Okay, and thank you all of you to watching whole the session, so patiently giving the answer. And yeah, I enjoyed session with all of you. So you have any doubt, any query, you can reach out us. Join the free WhatsApp group. I will share the content and all that there. Batch already started. You want anything, query, anything, you can call on us. Okay, call on this. Thank you. Good night to all.